Hey Nat 5, so as usual I've got a starter for you, 6 questions. I want you to pause the video, do the questions, and then I'm just about to go over them. So, question 1, what do we call a substance that neutralises an acid? Very simple, it's a base. Okay, remember, if the base is soluble in water, it's an alkali. Question 2, write the overall general equation for when an acid reacts with an alkali. Again, this is one of the equations that you are just going to have to know. So it is hydrogen ions plus hydroxide ions give you water. Okay, and that's the state symbols. AQ for an aqueous solution, then L for a liquid. Question 3, name the salts in the following reactions. So nitric acid, calcium oxide. Remember, you take the first name of the base, so it's going to become calcium, and you change the acid, so it's nitric acid, so it's going to become calcium nitrate. The next one, hydrochloric acid, lithium hydroxide, same idea. Take the first name of the base, which is lithium, and you change the acid, so hydrochloric acid becomes lithium chloride. Okay. Question 4, what must be first be done to solids and gases before pH is recorded? They have to be dissolved in water. Okay, otherwise you can't record the pH. Question 5, compound X dissolves in water and turns pH paper blue. Which one is true for compound X? Now, this bit here, if we are turning pH paper blue, that tells us it has to be an alkali. So it's a pH greater than 7. Okay, now if we've got more hydrogen ions than hydroxide, that means it's an acid. If we've got hydrogen ions equal to hydroxide ions, that means it's neutral. So if we've got less hydrogen ions than hydroxide ions, or if you look at it as we've got more hydroxide ions than we do hydrogen, that makes it an alkali. So our answer is C. Okay, and then final question, what happens to the pH when aluminium oxide dissolves in water? You may wish to use the data booklet. So you would need to use this page here, page 8, and what was it, aluminium oxide. If you look at aluminium oxide, there it is, aluminium oxide, it's insoluble. Okay, so that means nothing would happen, so the pH remains, obviously because we're dissolving it in water, the pH remains 7. Nothing happens to the pH. Okay? Right. This is our heading for today, so it's neutralization part 2, and we are on lesson 5. Okay, so last lesson we looked at what happens when we react an acid and a metal hydroxide. Okay, today we're going to do the other two. So the first one we're going to do is acids and metal oxides. Okay. So, again, you already know this, but we need to keep going over it. Metal oxides are bases. Yeah, they neutralise acids. Those that dissolve, okay, those that dissolve in water form metal hydroxides. Okay, Now obviously because it's dissolved in water, that makes it an alkali. And the second wee note here, as with all bases, when reacting with acids, they remove hydrogen ions. Okay, and because we're removing hydrogen ions from the acid, that causing the acid to neutralise. Okay, so the pH of that acid starts to go towards 7. Yeah. Now, what you need to know is the equation. So an acid plus a metal oxide gives us salt plus water. So it's exactly the same as if we had an acid and a metal hydroxide, alkali. We're getting salt plus water. Okay? But just make sure you know that. So we're going to do a couple of examples. Move that up a bit. So, example 1, we're going to go for hydrochloric acid plus calcium oxide. Okay, now we know that that's going to give us water. Yeah, now it's also going to give us a salt. We need to know how to name that salt, and hopefully you can already do that. Remember, we take the first name of the base and then we change the acid, and you can use that table that we created in lesson 4. So the first name of the base is calcium, and then the acid is hydrochloric acid, so that becomes calcium chloride. Okay, and that's the name of our salt. Now, what we can do, we can write the formula out. So hydrochloric acid, HCl. If you did SVSSF, you would be able to work all this out. However, you don't have to here, I'll just do it for you. So calcium oxide, CaO, and then that goes to calcium chloride, CaCl2, and then obviously water, H2O. Now, what I'm going to do is I'm going to change these into their ions. Okay, now you won't have to do this. I'm just showing you how I'm getting the equation. So H plus Cl minus plus Ca2 plus O2 minus. Remember, that's just writing our ionic formula. Again, you would do SV, SSF to get the formula, and then IF to get the ionic formula. Okay, but like I said, for this part, you don't actually have to do this. I'm just showing you how it's done. Now, what I can do, okay, if we have any ions that are on both sides, so for example, Ca2 plus, Ca2 plus, they're on both sides of the arrow, what we can do is we can cancel them out. Okay? And we would call these type of ions spectator ions, but don't worry, I'll come on to that in a future lesson. So Ca2 plus Ca2 plus can cancel. Not only that, but oh sorry, I should have balanced this equation. Put a 2 there, put a 2 there. And what can happen, the 2H plus here can leave the 2H plus in, sorry, the 2Cl minus and the 2Cl minus here can cancel, and what we're left with, sorry, that 2H plus shouldn't have cancelled, so what we're left with is 2H plus plus O2 2 minus, and that goes to H2O. Okay? So just remember that equation. 2H plus O2 minus goes to H2O. Now, I'm going to do a second example. Magnesium oxide. We'll choose a different acid this time, so we'll go for sulfuric acid, and obviously that will give us water, and the salt, hopefully you can work out. Again, we take the first name of the base, so magnesium, and we change the acid, sulfuric acid, so it becomes magnesium sulfate. Okay, magnesium sulfate. And if we write the formula out, so that's going to be MgO plus H2SO4. That would be MgSO4 plus H2O. Okay, I can put the state symbols in. Okay, so they're all aqueous, and then the water is a liquid. And remember, if it's aqueous, it's in solution. Yeah, so that means it will have ions. The ions will be free to move. So I'll put the ions in. So that's Mg 2 plus O2 minus plus H plus, we've got 2 of them, and then that's SO4 2 minus, and then that goes to Mg 2 plus SO4 2 minus plus water. Okay, now again, what we can do, we can cancel out the ions that are on both sides. Remember, we call these spectator ions, but I will come on to them later in a future lesson. So we've got Mg2 plus on the left, we've got Mg2 plus on the right, so we can cancel them. Yeah, we've got SO4 2 minus on the left, we've got SO4 2 minus on the right. Now you don't you don't need to be able to do this. I'm just showing you how it's done, and what we're left with 2H plus plus O2 minus, and that goes to H2O in the liquid form. And you'll see, or hopefully you see, is that is exactly the same as that equation there. Now it wouldn't matter what acid we used, what metal oxide we used, we would always get this equation. Okay, now this is a very important equation, and this is known as the overall general equation for acids reacting with metal oxides. Okay, so that's your 2H plus aqueous plus O2 minus aqueous, and that is going to H2O liquid. Okay, so very much like the acid and alkali one, where it's H plus OH minus goes to H2O. This one here for acids and metal oxides is 2H plus O2 minus goes to H2O. You must learn that. Okay, it's essential because it can come up. You can be asked for it. Okay, right. So the final reaction we need to do is my favourite one, and it's acids plus metal carbonates. Okay, now metal carbonates, obviously that's one of our three bases. Yeah, metal oxides, metal hydroxides, metal carbonates. Now, metal carbonates are a wee bit different. Okay, so if you have an acid and a metal carbonate, okay, you, as with the other two, would get salt plus water. However, it's a wee bit different because you get a third product. Yeah, and that third product is carbon dioxide. Okay, carbon dioxide. So, and this is they like to put this question in all the time. They'll give you a reaction between an acid and a base. They'll give you the base as being, for example, potassium carbonate, and you need to recognise that because it's a carbonate, you're going to get carbon dioxide as well. Okay, now the reason we're getting carbon dioxide, obviously because it's a carbonate, so it contains carbon, but it's an 8, and hopefully from third year you should remember that if a molecule compound ends in 8, one of the elements has to be oxygen. Okay, so that's where that carbon dioxide is coming from. So let's jump straight in. Let's do examples. And let's go for hydrochloric acid. We'll react that with magnesium carbonate, and what we're going to get is we're going to get a salt. Okay, let's name the salt. Remember, we take the first name. Yeah, naming the salt never changes. We take the first name of the base and we change the acid. It's hydrochloric acid, so the salt becomes magnesium chloride. Yeah, we are going to get water, and remember, because it's a carbonate, you need to be able to recognise that. Because it's a carbonate, we're also going to get carbon dioxide. Okay, do not forget that. Now, I'm going to write out the formula. So that's HCl aqueous, that's going to be magnesium carbonate, which is a solid, and magnesium chloride, which is MgCl2. All I'm doing here is using SVSSF, and that is it there. Okay. Now, if we wanted to balance this, again, I'm not going to show you how to balance it. You know how to balance it. If you want to do it on your own, by all means. But you put a 2 there, and that balances it. That makes everything balanced. 2 chlorines, 2 chlorines, 2 hydrogens, 2 hydrogens, so on. Okay. Right. So what I'll do, we've got 2H plus Cl minus plus Mg2 plus CO3 2 minus, and that goes to Mg2 plus Cl minus 2 plus water plus CO2. Now you won't need to be able to do this, yeah, create this equation. I'm just showing you how we get to the final equation. Now remember, we can cancel anything that's on either side, so we've got Mg2 plus on the left, and that can cancel the Mg2 plus on the right. Yeah, we've got 2 chlorines on the left, and we can cancel out with the 2 chlorines on the right. Nothing else cancels, so what we're left with is 2H H plus plus CO3 2 minus, and that goes to H2O and CO2. Okay. Right, if we try another one, so let's go for example 2, nitric acid, and we'll go for sodium carbonate this time. Sodium carbonate. Now, again, like we always do, we take the first name of the base and we change the acid. So this becomes sodium, and because it's nitric acid, nitrate, sodium nitrate. Now, that's our salt. We're going to get water, and remember, look, we've got a carbonate, so we're going to get carbon dioxide as well. Yeah? Carbon dioxide. So if I write this out very quickly, nitric acid, that's one of the three acids that you need to know. Yeah, the formula of, just off by heart. Sodium carbonate, you can do SVSSF for, get that. Sodium nitrate, again, do the same thing. Plus water, plus carbon dioxide. And again, if you want to balance this, you would need to put a 2 there and also a 2 there. Okay, if I write out the ions, it becomes this. Okay, so 2H plus NO3, oh, forgot my minus, plus 2Na plus CO3 2 minus, forgetting all my charges, 2Na plus NO3 minus plus H2O plus CO2, so we can cancel out the ions that are on both sides. Can anyone remember what that's called? It's called the spectator ions, so we can cancel out NO3 minus and NO3 minus, and we can cancel out the Na, the 2Na plus and the 2Na plus, and surprise surprise, what we're left with is 2H plus plus CO3 2 minus, and that goes to H2O plus CO2. And again, that's exactly the same as the one we did there. Yeah? Okay, now again, writing a different pen, the overall general equation for acids plus metal carbonates is this here. So you've got 2H plus aqueous plus CO3, CO3, 2 minus, that should be a solid, that goes to H2O is a liquid, and obviously CO2 is a gas. Okay, so please make sure you are learning that equation. So that's 3 neutralization equations that you need to learn. If it's an acid and an alkali, it's H plus plus O, H minus gives you H2O. If it's an acid and a metal oxide, it's 2H plus plus O2 minus goes to H2O, and if it's a acid and a metal carbonate, it's 2H plus plus CO3 2 minus, and that goes to H2O, and it also gives us carbon dioxide, remember? Yeah? Right, we're going to do one last thing, and then that'll be us. naming, I'm going to go back to salts, naming salts from carboxylic acids. Okay, so again, this is going to sound very obvious, but you have no idea how many people make this mistake. Carboxylic acids are acids. Okay, a lot of people, they just don't make that connection. I don't know why, but that's the way it is. Carboxylic acids are acids, therefore contain the hydrogen ion. Okay, and they are weaker than the others. Okay, that's like your hydrochloric acid, your sulfuric acid, your nitric acid, etc. Okay, so I'm just going to give you a wee note here. If it's methanoic acid, that gets converted into methanoate. Yeah? If it's ethanoic acid, what's the common name for ethanoic acid? Can anyone remember? It's vinegar. Okay, remember that? And that will get changed into ethanoate. Yeah? Now, pretty straightforward. Propanoic acid gets converted into, yep, you guessed it, propanoate. Yeah, and that's the same working up all your carboxylic acids. Yeah, butanoic, I'll do one more. Butanoic acid, that gets converted into butanoate. Okay, pentanoic acid would get converted into pentanoate. Hexanoic acid, hexanoate, heptanoic acid, heptanoate, octanoic acid, octanoate. Okay, so examples. Yeah, love an example. Let's go for sodium. We'll do two. Sodium hydroxide plus propanoic acid. What products are we going to get? Now, remember, it's hydroxide, so we're going to get a salt plus water, and the name of that salt, remember, we take the first name of the base, we change the acid, and that gets, so that's sodium, so carboxylic acid, so propanoic gets converted into propanoate, so that is sodium propanoate. Now the second one, we'll do one more. Let's go for pentanoic acid, and we'll combine that with calcium carbonate. Okay, so let's name the salt. So we take the first name of the base and we change the acid, so the salt becomes calcium pentanoic, gets changed into pentanoate. Okay, and obviously we're going to get water. However, big however, we've also got a carbonate. Okay, and because we've got a carbonate, we get a third product, and that third product, of course, is carbon dioxide. Okay, so just remember, carboxylic acids are in fact acids. Yeah, just a wee bit weaker than the rest of them. And to name the salt, we change the oic to oate. So propanoic acid becomes propanoate, butanoic acid becomes butanoate, and we always take the first name of the base. Okay, right, that's us. Thank you.